Hi everyone, this is Melody Rondeau and I'm going to be taking us through the lesson Solving by Taking Square Roots. Our learning intention, I'm learning how to solve quadratic equations, and our success criteria, I can solve quadratic equations by taking square roots. So let's jump in. All right, so the first example here we have x squared equals 25, and I have no doubt that you guys basically know the answer to this one without solving it, but we're going to use this as our jumping off point to help us understand some more complicated ones. So our way of solving, like we solve any equation, is we do inverse operations. So if it's add, we subtract. If it's multiply, we divide. When something is squared, we're going to take the square root. And we're going to do that to both sides of our equation, just like we add something to both sides or subtract it. We're going to square root both sides. And if you recall, the square root asks what number times itself. So we're going to think about that. What number times itself would give us 25? So if we, sorry, I'm getting ahead of myself. So I just want to point out first, actually, before we jump into the 25 part, the x squared and the square root. How this works is we'll eventually say the square root and the square cancel each other out. But what's really happening is x squared, we hopefully remember, is x times x. And you might recall a square root, it takes two of a kind to get out. So there's my two of a kind, which means an x gets out of the square root. So our shortcut version of saying that is basically that it cancels out. But it is actually simplifying a square root. Okay, so the 25 business, the square root of 25, remember, means what number times itself. So, and I'm sure we already know this, we could fill this in, no problem. But just a reminder, it has to be the same number. So I've got to do the same number in both blanks. So I could say the obvious one here, which is 5 times 5. And so I'd go, oh, what number times itself? Oh, the number is 5, or 5 squared would give me 25. However, there is a catch, and I think we talked about this before, that there's actually another way to end up getting 25. If I do a number times itself, there's one other number that can do this. And that particular number, if you haven't already figured it out, is the negative version. If I take a negative 5 and multiply it by itself, a negative 5, negative times a negative makes positive. So when we are solving an equation, not just simplifying a radical like we did before, we're finding square roots, but solving an equation, and we have to take the square root in order to solve. We put in that square root symbol ourselves. We have to say all the possible answers for x. So I have to say plus or minus. The symbol here meaning, I'm going to rewrite it here, meaning that it could be the answer is a positive 5 or the answer could be a negative 5. The way we read that is plus or minus 5. So x equals plus or minus 5. That symbol is called plus or minus. It means it could be positive or negative. It's like before when we listed it out as, we would have said, listing out all the answers, like in our previous notes, we would have listed this as negative 5 and positive 5. So it's the same thing, but we're going to start to write it with that plus or minus symbol. All right, so with that in mind, let's take a look at example 2. We want to solve for x, so we're going to use our regular solving equation skills, inverse operations here. I want x by itself, so I'm going to start by getting rid of the 3. So I'm going to add. So add 3 on both sides, this goes away. I get 2x squared equals 24. I'm going to continue solving for x, so I would divide both sides by 2, and I get x squared equals, let's see, 12. 2's cancel out. Good. All right, then my final step here is to undo or get rid of the squared or take the inverse, which would be square roots. So the opposite of squaring is square rooting. Here's where I'm going to do that shortcut version of those cancel out. I get x. I'm going to have to work with this square root more in a minute, but first, because I put the square root into my problem, I'm going to make sure that I put in as part of my answer the two options that my answer could be a positive or a negative. Then I'm going to look at 12. Square root of 12, is 12 a perfect square? No, it's not. But I am going to look at whether or not I can break it down. So I'm going to kind of do this on the side. to try to basically simplify the square root of 12. 12 breaks down into 4 and 3, or 2 and 6. You could do either way. 4 breaks down into 2 and 2. The 2's don't break down. The 3 doesn't break down. I'm looking for 2 of a kind. I have a pair right here, pair of 2's. So a 2 gets out, and then we have that 3 left over in the root. So our answer would be plus or minus 2 times the square root of 3. Alrighty, on we go. All right, so continuing, notice the directions, find the roots. So using the different vocabulary words we talked about in the last lesson, we can call the answers to a quadratic zeros, roots, solutions, x-intercepts. This case, we're calling it roots. All right, so this one may look crazy complicated. We're trying to get to x. We cannot get to that x until we deal with the parentheses squared. Before I do that, I want the parentheses squared to be by itself. So I really want to start this problem by getting rid of this 4. So I'm going to move 4 to the other side. Again, remember my goal is to get the x by itself. So I have 4x plus 1 squared equals 4. At this point, the only thing, I can't do anything in the parentheses until I get rid of the squared. So I'm going to square root both sides, do the opposite, square root. And on the left-hand side, I know those are going to cancel. So I have 4x plus 1. On the right-hand side, because we put that square root in, we're going to also put in the plus or minus to show there's 2 options, a positive version and a negative. And then I'm going to ask what is 4 a perfect square? What number times itself is 4? This one does have an answer. It is 2. So we get to that point, and now we have this weird plus or minus thing in our problem. If you are able to, meaning you just have a number here and no square root, like the last one, let's go back for a quick second. We have plus or minus 2 times the square root of 3. So we had a square root still in our answer. If you still have a square root in your answer, you're just going to leave it. But here, because we have just plus or minus 2, we're going to split this based on that plus or minus. We're going to say, well, 4x plus 1, it could equal a positive 2, or 4x plus 1, it could equal a negative 2. So those are our 2 options, or the 2 possible outcomes for that previous square root of 4. All right, so I'm going to solve each one of these. So I'm going to start with this one. I subtract 1 from both sides. 1 minus 1 is 0. I get 4x equals, looks like 1. 2 minus 1 is 1. Divide both sides by 4, and I get x equals 1/4. For the other one, subtract 1 from both sides. I get, let's see, 1 minus 1 is 0. 4x equals negative 2 minus 1 gives me negative 3. Divide both sides by 4. I get x equals negative 3/4. So for this one, I have 2 values, so I'm going to list them out together. I'm going to say negative 3/4 and 1/4. And you will notice that sometimes our answers will be 2 different numbers, as opposed to in this last one where it was just plus or minus and a single number, or even in example 1, plus or minus 5. Sometimes it will be something like this in example 3, where we have 2 just different numbers. All right, so that finishes example 3. Let's go on to example 4. We're going to continue here solving, finding the roots. So again, my goal is to get to the x. To get to that x, it's in parentheses that are squared, so I've got to get that squared part of the deal by itself. So that really means I'm trying to get rid of the 2. So I have to decide what operation is happening between the 2 and the parentheses. So that would be multiplication. So the opposite would be division. So we are going to divide both sides by 2 to get rid of that 2. So let's see, divide both sides by 2, and then the 2's cancel, and I have x plus 1 parentheses squared equals 18. All right, so then now I just have parentheses squared. I'm going to get rid of the squared by doing the opposite, or the inverse, taking the square root. So the opposite of squaring is square root, and I'm going to do it to both sides. All right, so square and square root cancel. I get x plus 1. Then the 18, square root of 18, I'm going to immediately put in my plus or minus. Again, anytime we put in a square root, we're putting in that plus or minus. Then I'm going to work on 18 on the side and see what I can do with it. 18 itself, I didn't ask, but 18 is not a perfect square, so we are going to be doing breaking it down. And I'm going to do 6 and 3, but you could have done 2 and 9. 3 doesn't break down, but 6 will break down into 2 and 3. 2 doesn't break down. 3 doesn't break down. I look for any pairs. I happen to have a pair of 3s, so a 3 gets out, and I have a 2 left inside. So this one we are not quite finished yet because we have x plus 1. Remember, we're trying to get x by itself. So I still have to do this last step here and move the 1 to the other side, which is going to look a little weird. So here, plus 1 and minus 1 cancels. I get x. So I have x by itself. On the right-hand side, anytime you have, again, the situation with the plus or minus, if it's just a number, we'll actually split it and say do one where it's positive 3 and one where it's negative 3. This one we have a square root, so we're going to kick that whole thing to the back and just leave it with the square root. So the minus 1, I'm actually going to move that to the front, and I'm going to kick the plus or minus 3 square root 2 to the back, and this actually becomes my answer. Negative 1 plus or minus 3 times the square root of 2. All right, we got one to go. Last one. We have find the roots, and we'll talk about the solve by factoring thing in a minute. So I'm going to just do find the roots. I want to solve for x, so I'm going to start by doing some inverse operations here. Let's add 9 to both sides. And I get 25x squared equals 9. Then to get x by itself, I'm going to divide both sides by 25. 25 cancels, I get x squared equals 9 over 25. And to get rid of the squared, we do the opposite, which is take the square root of both sides, square and square root cancel, I get x equals. So here I have this crazy square root of 9 over 25. Once upon a time when we were simplifying square roots, we talked about how we can actually split that into square root of 9 over square root of 25. If I do that, I happen to know the square root of 9, and I'm getting ahead of myself. Pause. There's something that we missed. Not really. I missed it. I apologize. Let's make sure we get this in here. Anytime we have a square root, or we put the square root into our problem, we're going to throw in that plus or minus. That's what I forgot to add in right there. Let me sneak it in, and then let me rewrite this. Okay, so let's put in the plus or minus, and then we have square root 9 over square root 25. There we go. All right, so we can simplify that now. We still have the plus or minus. Square root of 9, we know what that is. That's 3. And square root 25, we know what that is. That's 5. So we end up with x equals plus or minus 3 over 5. So we have positive 3 over 5 and negative 3 over 5. All right, so this one I wanted to show us because that's where I'm being asked to find the root. So we did solve by taking the square root. But this particular problem we could have solved by factoring. So I want us to see that. So we're going to go ahead and solve this one by factoring. So notice it equals 0, so we know we're going to be doing that 0 product property. But first I'm just going to jump into my factoring. I'm going to look for a greatest common factor. There isn't one. Then I see only 2 terms, and you may recall when there's only 2 terms we do something. Let me go back. Hold on. Hold the phone. Okay, we do something called difference of squares. That was a newer concept we learned just at the end of the last unit. So difference of squares is a special factoring we do only with 2 terms. We have to have a difference or a minus sign, and we have to be able to write our problem as everything being something squared. So all of our stuff has to be written as something squared. So there we go. In my first term, what squared makes 25? It would be 5. What squared is going to give me that x squared is going to be x. So 5 squared is 25. X when I square it is x squared. Then 3, when I square it, gives me 9. Then the difference of squares factoring says we take those things and jump straight to parentheses. I take what's in the front, and that goes in the front, so 5x, 5x, and then what's in the back, and that goes in the back, 3 and 3, and then different signs. And then here's where we pick up the solving. So that's the factoring part, difference of squares. The solving part is, we talked about in the last lesson, doing zero product property. So when I have two things multiplied, so here's my thing 1, or we called it A, and then here's my thing 2, which we called B. When I have two things that are multiplied that equal 0, I know for sure at least one of them equals 0. So I'm going to set each part equal to 0 to figure out all the options for x, like so. All right, and then I'm just going to solve these with my regular writing utensil. I'm going to subtract 3 from both sides. And I get 5x equals -3. Divide by 5, and we get x equals -3/5, which was one of our answers that we already know. You had plus or minus, or positive, or a -3/5. So there's the negative. When I solve this other one, I'm going to add 3 to both sides. So I get 5x equals 3. Divide by 5, and I get x equals the positive 3/5. So you can actually solve this one either way. The only reason to solve it one way or the other at this point is if you're asked to solve by factoring, then you would do difference of squares. If you're asked to take a square root, then you would do it like we did at first. So it just depends on what you're asked to do. And then when you're on your own, you can just do whichever way you prefer. And I believe that is our last example. So at this point, let's take a minute and check off our success criteria. Wow, if I can get that equal sign, good, that would be good. All right, so this is success criteria. I can solve quadratic equations by taking square roots. If you've got it, check it off, otherwise circle it, and you are good to go to get started on your practice assignment. We'll see you later.